All right, so welcome to the live homework FSA review right before we take FSA. So what I'm going to be doing is I'm just going to give a nice quick snapshot of everything that you should have learned as a 5th grade skill. Again, it's not intended to teach you, but rather to jog your memory of things that you should have learned throughout the year, and just remind you because we learn a lot of things and sometimes we forget, and so this is intended to give you that aha moment. So hey, for all of you that are joining in, and I'm going to go ahead and get started. So at the very beginning of the year, when we started in chapter 1, hey Adriana, when we started in chapter 1 with multi-digit multiplication and division, we used the acronym many zoos, many animals, which helped us with multiplication and division. We realized that when we are multiplying a multi-digit whole number, we would multiply and get a first partial product. We would drop a 0 representing that now we're multiplying into the tens place. We would multiply again and then add together our two partial products. Many zoos, many animals. We also did some fun questions where we were looking for a missing digit. And so please remember that when you're looking for a missing digit, you're going to, if there are answer choices available, you would try a middle number, one of them in their middle, get a final product, and then adjust up, adjust down. If there's not a missing number, hey Sophia, if there's not any answer choices, you would start with 5, and again, adjust up, adjust down. Then additionally, when we used in Unit 1, we also did some division with 2-digit divisors, which in this instance is the 32. And we said that when I have those 2-digit divisors, I can just find a nice, friendly, compatible number to help me. So if my divisor is 32, it's kind of close to 30, so I can use 30, list my multiples for 30. I know my 30s because I know my 3s. If the number was 48, I could do 50 because I know my 5s. If the divisor was 68, I could do 70. So a nice, friendly, round, compatible number. We also know our 25s very well, and we know our 15s very well because we know money and clock time. We also said that you can use the distributive property sometimes, and this number actually breaks down very easily when dividing by 15 because 45, which is equivalent to 4,500 because of the place value, can go into 15 evenly. And then 30 could be divided into 15 evenly. So you can break it down in certain instances by its place value understanding if it breaks into easy chunks. Doesn't always happen, but you can. Okay, then we moved into Unit 2, which was our numerical expressions. And so we talked about GEMDAS. So I recommend that you're always thinking about GEMDAS when doing order of operations. Write it down. GEMDAS. Again, remember to circle the M and the D, reminding you that multiplication and division are related fact families. Work them left to right. Hey, Alyssa. No, Allison. Hey, Allison. Such a dork. And then also please remember that addition and subtraction are also related fact families. So when you have addition and subtraction both in the same numerical expression, work it left to right. Oh. And as a total side note, please remember there's a difference between the word expression and equation. Expression means you're just given a like a number sentence. Equation means it's going to have the equal sign and must come with a solution. Expression, number sentence. Equation must have equal sign with an answer. So again, please remember that if it asks for an expression, you do not have to solve it. You're welcome in advance. I just saved you a lot of time. Anyways, going back here, if it's asking you in any situation to find an error, my recommendation is that you rework out the problem and look at it step by step. Ta-da! Then we moved into Unit 3. In Unit 3, we looked at volume. Please remember that volume is where you are filling or seeing how much an object can hold. It's 3-dimensional, how much can go inside of it. There are 2 formulas for volume which you must have memorized. Length times width times height, or base times height. Because remember that base is what you get when you multiply your length and your width. If you have to find a missing dimension in situations of volume, multiply the 2 dimensions that you're given and then divide. So in this instance, if I know that my length and my width are 6 and 4, multiply those 2 dimensions and then divide 24, the volume, by 24 to find the missing again. And if it asks you to draw a possible base, you are looking for you are looking for two numbers that can multiply together to equal the base. So if I decided that my base was 24, two numbers that multiply together could be 6 and 24, or 2 and 12, or 8 and 3. Boom. Draw it. 8 times 3. Boom. There'd be 24 units inside. You don't have to have the 24 inside. Just realize that there's 24 units because 3 times 8 is 24. Always remember to use cubes. Circle the number, what they mean. Underline the question. Box the operation word. Eliminate any distractors. Evaluate an equation because you're going to solve and show your work. Then I moved into unit 4, which was adding and subtracting fractions. Remember, when you're adding and subtracting, you must have a common denominator. So list your multiples, find your least common multiple. In this instance, it was 10, and then create equivalent fractions by multiplying your numerator and your denominator both by the same number. Remember that when you're borrowing from your whole number, in this instance, I had to borrow from my 4. It had to become a 3. When you're borrowing from a whole number, regroup into the fraction by adding the amount of the denominator. So when I borrowed from this 4 and it became a 3, I had to add back in my denominator. I added 10 more because 10 tenths equaled a whole. So I had 5 tenths, but plus 10 more, now I have 15 tenths. Boom. To find a missing digit, we talked about how you can use the relationship between addition and subtraction. And I could rewrite this as subtraction, my whole minus my part. Or I could just take this out. I could just take this whole thing out and figure out 1 3/8 plus what equals 3 3/4, common denominator again, and fill in what it would be. Then we moved into chapter 5, which was multiplying fractions. We said when you multiply a fraction, it's your numerator times your numerator, your denominator times your denominator. When you're doing that same information with a mixed number times a mixed number, you can turn your mixed number into an improper fraction. Whole number times your denominator, add it to your numerator, boom. Then multiply. If they're both mixed numbers, then you're going to have to convert both. If this was a fraction, I just drop the fraction down. Again, numerator times my numerator, denominator times my denominator. Make sure you take it back to a mixed number if that's how it's representing your answer choice. We moved on to chapter 6, division of fractions. Keep, change, flip. Always keep, then change, flip the second. So I always keep the first, change the multiplication, flip. The reciprocal of 1/4 is for a whole. Again, keep, change the sign, flip. The reciprocal of 1/5 is 5 whole. Doesn't matter what your first number is, it's always going to be keep the first number, change the sign 2 times, flip to the reciprocal. Boom. And if I were to do 5 divided by 9, 5 divided by 9 is the same thing as saying 5/9, because please remember that division is the same as a fraction bar. Boom, drop the mic on that junk. Then we also did some line plots with all of our operations with fractions. So some friendly hints to find what your line plot is divided into. Count your intervals from one whole number to the next whole number. That will tell you what it's divided into. This one was divided into 8ths. If I want to find the difference between the longest and the shortest, I would look at the longest, figure out what it is. Let's see, this is 3 and 1, 2, 3, 4. 3 and 4/8 minus 2 and 2/8. 3 and 4/8 minus 2 and 2/8. Boom, subtract, ta-da, difference between the longest and the shortest. If I want to find something that's a certain number of times longer than the shortest, if it said 3 times longer than the shortest, I would find the measurement of the shortest and multiply it by 3. The measurement of the shortest is 2 and 2/8, and then I'd multiply it by 3 times longer. Boom. We then moved into chapter 7, which was classifying our two-dimensional figures. We did a lot with Venn diagram work, so we had to figure out, generate what rule was used on this side that did not match this side. So on this side, I could say it has 2 pairs of parallel lines, but unfortunately that rule would work for that side too, so that was not the rule. What other attributes does it have? Oh, all congruent. Does this have all congruent? No, it does not. So this rule must be all congruent. Let's see, what does this side have that that side does not? Oh, 4 right angles. So this is all congruent. This is 4 right angles. And let's see, where would a square go? A square is all congruent. Oh, but a square also has 4 right angles, so it's going to go in the middle. Where would an equilateral triangle go? An equilateral triangle is all congruent. Does not have 4 right angles, so it would go in the middle. We did a hierarchy, and we said with our hierarchy that we have all closed figures with 3 or more sides are polygons, and then a 4-sided figure is a quadrilateral. So we have different types of quadrilaterals. We have a kite and a dart, which have no parallel sides. We have a trapezoid, which has one set of parallel sides. You can have a right trapezoid, which means it has a right angle, or an isosceles trapezoid, which means you have 2 sides that are congruent, 2 sides with equal length. And then we have several types of parallelograms. Remember, a parallelogram has the word in it, parallel. Parallelogram has 2 pairs of parallel sides, 2 sets of congruent sides. Within a parallelogram, you have a rhombus, which has your 2 parallels and your 2 congruent, but it also has all 4 congruent. You also have a rectangle, which has the 2 pair parallel and the 2 pairs congruent, but it has 2 right angles. That should say 4 right angles. That's 4 right angles. Then, sharing the attributes of both a rhombus and a rectangle is a square. A square has 4 right angles from the rectangle, 4 congruent sides from the rhombus, and still the 2 pairs of parallel and the 2 pairs congruent. So each time you're traveling down, you're adding an attribute, making it more specific. So we have some general rules. When I'm traveling across, the rule is never, as in a parallelogram is never a trapezoid. A kite is never a parallelogram. A cross is never. Your other rule is from the bottom up is always. A square is always a rectangle because a square has all the attributes of a rectangle, but plus some more. A square is also always a rhombus because it has all the attributes of a rhombus, but plus some more. So each time you're going down, you're getting more specific. From the top down is sometimes. A rectangle is sometimes a square, but it's not always a square. In order for it to become that square, it has to have those 4 congruent sides. So a rectangle that is not a square is a rectangle. A square that is not a rectangle is a square. A rhombus that is not a square is a square. I mean, it's a rhombus. That kind of thing. Okay, anyway, so let's move on. Then we also said you can classify triangles by the number of sides that they have and by the angles. So when I look at the sides, I told you to put them in alphabetical order. E-I-S in alphabetical order. E, equilateral, equal. All 3 are equal. Isosceles, 2 eyes, 2 equal sides. Hey, John. Isosceles, 2 eyes, 2 equal sides. And a scalene, if a scale is leaning, it is uneven. So no even sides. Equilateral, 3. Isosceles, 2. Scalene, 0. Again, put them in alphabetical order. Equilateral, all equal. Isosceles, 2 eyes, 2 equal sides. Isosceles, scalenes are uneven. Boom. You can also classify it by its angles if it has acute, right, or obtuse. In order for a triangle to be an acute, all 3 must be acute. All triangles have acute angles. They all have at least 2. If they have all 3, it's acute. A right triangle has 1 right angle with 2 acute. An obtuse angle has 1 obtuse with 2 acute. So again, they all have at least 2 acute. In order for it to be acute, all 3 must be acute. Pretty simple. Again, acute means less than 90 degrees because it's so cute and tiny, and obtuse is obese a little bit. It's really big. So yeah, that's it. And remember that a triangle will be named by both of them. An equilateral can be acute and an equilateral can be obtuse. An equilateral cannot be a right because that right angle cannot have all 3 sides equal. But remember, they can be named by all the names. And if you want to YouTube it, don't forget, type in YouTube, Triangles song. You can listen to my Triangles Radioactive song that we listened to this year. After we were working on Unit 7 with shapes, we then moved into Unit 8. So here was Unit 8. With Unit 8, we talked about graphing on a coordinate plane, and so we generated some rules. Again, you have to figure out what the rule is. Sometimes it'll give you a rule. In this instance, this told me to start at 0. The rule was multiply by 2, then add 1. So I started at 0 and multiplied by 2, add 1. 0 times 2, 0 plus 1 is 1. You have to do both of the rules before you generate the number. So again, 0 times 2 is 0 plus 1. Boom, generated my number is 1. 1 times 2 is 2, plus 1 more is 3, generated my number. And so on and so forth. 3 times 2 is 6 plus 1, my next number would be 7, and continue it. Same difference here, multiply by 2, add 2, so 0 times 2 is 0, plus 2 is 2. 2 times 2 is 4, plus 2 is 6, and you continue it, so on and so on. And then those numbers can be used to graph on a coordinate grid. Remember, I'm going to run across my x-axis and then jump up my y. I think about a long jump. Run first, then jump up. Here is a pattern table. You might have to identify a missing number. Please notice the rules going laterally. For every 1 batch, I need 2 eggs and 6 cups of flour. So 1 times 2 is 2. Times 2 is 4. Times 2 is 6 times 2. So this rule is times 2, which means this missing number here, 10 times 2 is 20. Same thing here. There's a rule. What is the rule? What did I do to go from 6, from 4 to 12, from 6 to 18, from 10? The rule was times 3. Boom. Done. Okay, then let's move into Unit 9. Unit 9, place value. Remember that this exponent up top tells you how many times to multiply the number 10. I would multiply the number 10 4 times. This is like saying 10 times 10 times 10 times 10 times 10. In other words, how many times to move over each place value? Because each time I move over a place value, my number is becoming 10 times greater or 10 times less. So we also talked about these comparisons today. The word is can be substituted for an equal sign, and times can be substituted for the multiplication symbol. Work out what's on the one side and see does it equal what is on the other side. Also, THT, tens, hundreds, thousands. Remember that the decimal point represents the word and. Look at your chunks. What is the chunk before the decimal? When I see the decimal, I say the word and. Look at the chunk after, and then the place value. So here I have 10 and 675. Place value of the 5 thousands. 10 and 675 thousands. Chant it in your head. THT. 10, hundreds, thousands. Then we had this little dilly bob here. I can multiply this by 10 to the power of 3. Tells me how many times to move the decimal. If I want to multiply by 1,000, tells me how many times to move the decimal. Count my zeros, move it that many times, same difference. Expanded form, this right here threw a couple people off today. When it's saying times 100, I could work it out. 7 times 100 is 700. 8 times 1/10 is 8 tenths. 5 times 1,000th is 5 thousandths. Or put my 7 in my hundreds place, put my 8 in my tenths. There's nothing for my hundredths, so I put a 0. Put my 5 in my thousandths place. And then we talked about some rounding rules. Find the number, look right next door. 5 or more, raise the score. 4 or less, let it rest. Boom, rounding rules. We then moved into Chapter 10. Chapter 10, operations with decimals. When we're adding and subtracting, line your decimals straight up. Add the numbers, drop down your decimal straight down. With multiplication and division, your decimals do not line up. For multiplication, you use your powers of 10 to place the decimal. For division, you have to make sure your divisor is a whole number. If it's not, you have to move it over to make it a whole number. What you do to your divisor, you must also do to your dividend, just like an equivalent fraction. Then bring it up, divide it like a whole number, multiply it like a whole number, multiply a whole number, divide like a whole number, multiply, divide, multiply, divide. Line them up, drop them down. And then the final unit that we covered was conversions. For conversions, please remember that it is only a conversion is necessary if the units are unlike units of measurement. For instance, if it's talking about gallons and quarts. Just because it uses the word quarts does not mean it is a conversion unit. Pay attention. Only if it is an unlike unit. On your reference sheet, please remember that the left side is always your bigger unit and that the right side is your smaller unit. Some acronyms that we said is if I'm going from a bigger unit to a smaller unit, I'm going to multiply. Best, soccer, mom. If I'm starting at the smaller unit and I'm moving to the bigger unit, then I'm going to divide. Silly babies dancing. So please, again, always the left side is always your bigger side. The right side tells you the number to multiply or divide by, but it also is your smaller unit. Remember the metric system is you're multiplying and dividing by powers of 10. How many times are you moving that decimal? Metric system is your powers of 10. And then here's an example. If I said that I had 8 tenths meters and I want to turn it into kilometers. No, I had 800. If I had 800 meters and I wanted to turn it into kilometers, I'm going from meters to kilometers, which means my decimal is also going to be moving that same direction to the left. So I would take it and move it decimal on whole numbers at the end, move it 1, 2, 3 times. Now it's in front of the 8. Drop those dead zeros at the end. Remember they're equivalent, so if they're represented in an answer choice, it is fine. But we as mathematicians tend to drop them at the end. 8 tenths would be that answer. So that is it for the math review for tonight. I tried to cram everything in. Imagine that, an entire year worth of 5th grade work crammed into just 20 fabulous minutes of fun. Because I talked fast, I do recommend that if you truly are trying to study, go back, watch certain parts if you want to watch certain parts, look over the notes again on your own, put it into your head, look at them. If there are certain things that you're wanting, say them again and again. Go over the triangles, the attributes of your shapes, anything that you're not completely sure of. Take that extra time tonight to study, because studying is what's going to set you up for success. I have had to do the same thing as I traveled through college, as I've ventured into new career opportunities. That is what makes you successful. Take that extra time and do it now, and you will not be disappointed. Have a great night, guys. Remember to get extra sleep. If you have any questions, you need any clarification, leave it in the comments. Drop it down there. Drop it like it's hot. Other than that, have a great night, guys, and I'll see you in the morning. Bye.